so that we're not doing this forever today. Spend enough time on it. So in this, we're going to start off. You need to be able to notice and recognize with this question that's being asked of you, what type of electromagnetic radiation is a photon that has 8.975 times 10 to the negative 16 joules? First thing you need to be able to recognize is, what is this number? Energy. The second thing you need to notice is how many questions you're being asked here. What type of electromagnetic radiation? There's the first question. If visible light stays the color. So you can say there's a second one, but it really is just that first question. Also state if this radiation is deadly to humans. This right here is as complex as a problem as I can make for you in this. Because you're literally looking at three parts. So let's deal with the first part. We've got to find out what type of electromagnetic radiation. And whenever we're doing that, what are we trying to find with that when we're trying to identify the electromagnetic radiation? The grand scheme thing we solve for.
Energy.
Frequency is part of it.
It doesn't move around it. It went to the same number.
Somebody said it.
Energy. Wavelength.
Wavelength.
We got all the answers yesterday.
Okay.
You are solving for wavelength. That's the grand scheme of it. But can you just get to wavelength?
You're telling me.
No, you cannot just jump straight to wavelength. So in this, you have to first start with what you've got and go to where?
Where you want to get to.
Hey, yeah, there we go. We got to go from energy, which we start with, to frequency,
And then from frequency
to wavelength. Remember what I told you in this. If you are not given frequency, asked to find frequency, you will go through frequency. Because the frequency links the two together. So in this case, energy equals Planck's constant times frequency. I'm trying to find frequency, so frequency is equal to energy divided by Planck's constant, which will be the energy that we're given, so 8.975 times 10 to the negative 16 joules divided by Planck's constant.
6.626 times 10.
That's right, 6-point stitch.
Yay.
I just like saying 626.
I just like saying stitch.
That works.
So we know what guy you would be, the little rabbit genius of Lilo and Stitch.
Sure.
I'd be Lilo.
Experiment 626. My best shot at it I got.
So where you go. I like it.
Alright, so in this you solve for that and you find a frequency of 1.354 times 10 to the 18th. And those are inverse seconds, which is also
Hertz.
inverse seconds, which is also hertz.
Or S with a negative thingamajiggy too, right?
Let's start with that.
No.
Test or quiz. Does it matter which one of the three we use?
Nope, don't matter at all.
Here's my
Does it matter if we change it? Like we start with inverse seconds and then
Wait for you to
somehow we just use hertz?
That's fine because of the identity, since they're equal. Alright, so in this case we now have frequency. So we're here. Booyah. Now from here, we need to solve another piece of information. We got to get to wavelength. So what equation will you use?
Speed of light equation thingamajiggy.
Speed of light equals wavelength times frequency. Good job. In this, we got to solve for wavelength. So wavelength equals the speed of light divided by frequency, which the speed of light is 2.98 times 10 to the 8 meters per second divided by the frequency we just solved for, 1.3545 times 10 to the 18th hertz. So hertz and seconds cancel out. Because remember, hertz is inverse seconds. which leaves us with 2.200 times 10 to the negative 10 meters. So there's wavelength. And if you want to, apply Maddie rule. So we get 2.2001 times 10. I'm going from meters, which is 0, minus nano, because I'm going to nanometers, to negative 9, so positive 9. Add to it what I originally start with, which is negative 10, so it equals negative 1. So that is the same as saying 2.2001 times 1 over 10, because that's all that negative sign's telling me. So this is our nanometers. If you're dying to find it in nanometers.
Do we have to?
You don't have to. And in this case, is that nanometers helpful to you?
No.
No, the nanometers are not helpful whatsoever. So in this, you got to go now to answer the question. You need the electromagnetic spectrum. Hold up a second. If you're watching the video, close your eyes.
Can I change the rule just a little bit?
No. Maddie's rule is Maddie's rule. Open your eyes. What do you want to change it to?
Only if it's starting out with negative 7 or negative 6. Because
Fair.
if it's not, then
Fits with negative 7.
Doesn't matter. Sure, go with that. In this case, look here. Okay? So Maddie's rule is helpless to us. It's not helping us. So in this case, we got to look back at meters. Because up here at the top, we have meters for our wavelength. Look at the exponent that you're given. So we have times 10 to the negative 10. Where do we find that times 10 to the negative 10 at?
X-rays.
Right here at X-rays. Now in this case, I will go on and tell you this is obvious. It's an obvious answer. If you were looking and saying what type of electromagnetic radiation this was right now, what would you say?
X-rays.
X-rays. Why are we going to say X-rays?
Because it falls in the X-ray.
It absolutely falls in X-rays. It doesn't matter because here's times 10 to the negative 11. Here's times 10 to the negative 9. All this is X-rays. Yes.
quick question. Could we leave it at frequency? I know that it's light and it's wavelength.
You can do it with frequency too because
That's
it's down here.
That's what I was. I just didn't want you to come at me. I was just asking if we just leave it at frequency.
Y'all act like I'm such a horrible person. No, that's absolutely fine if you want to do frequency. I just like to do the wavelength.
Because it was at 18.
Yeah. You can, but for me, I like to do the wavelength. But you absolutely can do it. That's absolutely fine.
So technically these problems could be solved in like one step.
Sure.
Alright, nice, great. One step. Literally one division problem.
But then you still haven't answered the question with that one step, so it's more than one step.
I mean, yeah, but in order to get the information that I need to know to answer those questions.
One division, yeah. All right, from in this. So look here. At this point where it says times 10 to the negative 10, that number is 1 point. I want red. .0 times 10 to the negative 10. Okay. You need to understand as you go from left to right and from right to left on the electromagnetic spectrum is numbers increasing or decreasing. So as we go from here to the right, so at this point right here, that number is 1.0 times 10 to the negative 9. Which one of those numbers is greater?
1.10 times 10 to the negative 9.
1.0 times 10 to the negative 9, absolutely. So in that case, as we move from left to right in terms of wavelength, as we move from left to right on this electromagnetic spectrum, does the numbers increase or decrease? They're increasing. So as you go left to right, those numbers are going to increase for you. In this case, my value in question is 2.2001 times 10 to the negative 10 meters. Where is it going to lie at? On the right of this or to the left of it?
Right of it.
To the right of it. So you're looking approximately somewhere right in here.
Yeah.
So what type of electromagnetic radiation is this? X-rays. If you're watching the video, close your eyes.
Okay, just out of just me saying this, again, don't want you to come at me. Why wouldn't it be closer to the negative 9? Because as you're going, like, it would be, I'm trying to make sense of it.
Okay, look at this. As we're going from 1, it goes from 1 to 10 over, right?
Yeah, but
So
wouldn't
how
that
far
be
over we
8?
going to go? Huh?
Wouldn't that be 8 where you marked? Because when you're going down, it would be.
Don't think of it like that. I know what you
No,
mean.
because you're looking, that exponential value's the same throughout there. As you're going left to right, this number is going to increase. So it's literally going to break down as you go. It's going to be like 1.0, 2.0, 3.0, 4.0, 5.0, and it's going to keep going all the way until it gets to like 9.9, and then it gets to 10, but it'll change at that point where it's a 10. When it reaches here, to where it should be 10, it becomes 1.0 times 10 to the negative 9.
Maddie, no. Okay.
Okay, so in this, look, this is the number line broke down. Where's 2.2?
Right there.
So like right in here? Where's 1.0? Where we made the line? Right here. Is that not what we did?
Yeah, but I was just saying it would go that way because as you're going down.
She's thinking of her like a regular number line. If you go negative, like the,
You have to look at how your number line's progressing.
So if it was 2.2001 times 10 to the negative 8, it would be placed like right after the negative 8 going from left to right.
Yeah.
So you read it going this way, the normal way, but once you hit that negative number, you read it this way.
Not really, you're not reading it from right to left.
Yeah, but it's decreasing going this way. Oh, I get it.
Got it now? Yeah.
Mr. Hall, I see why you say to go ahead and transfer it over to meters. Whenever you get to the visible light spectrum.
Alright, so in this, we've determined
Go ahead and do this.
what type of electromagnetic radiation is this?
X-ray.
X-ray. So there is one answer.
They are not.
Do we have to worry about this second part?
No.
No, it's not visible light, so you don't have to worry about it. But there's a third question, which technically is the second question. State if this radiation is deadly to humans.
Yes.
After a
It
certain
is.
point.
Says no, you say yes. What do y'all got?
No.
I put harmful. That's what my answer was. Yeah!
Explain why it's harmful.
Because it goes through your skin and it can cause cancer.
It can cause cancer. It's literally poking holes in the DNA. It
I
can kill.
remember.
kill you. It can cause cancer that will lead to your death.
Isn't it if it's past like visible light, it can hurt you?
Once you go past visible light, once you go into ultraviolet, you're hitting what is deadly. Remember, that whenever we're talking harmful or deadly, we're not talking, it's like, I just dropped a bomb on you. You're dead. Okay? It's not like I shot you with a gun. This is a, hey, junk happened, man. Okay? It's been a little bit too long in the tanning bed. Now I got this weird looking freckle coming out. I'm going to the doctor and they look at it and say, hey, you got skin cancer. Okay, that's what you're looking at in these terms. Any questions here on this problem? This right here is like Mad Daddy Central hard. Okay?
You take out one A in that and you got my name.
Okay. Yeah.
This is easier. I think this is more than that.
What other?
But this, I get that more than other that.
It's literally the same thing. All right. Do you have a question, Olivia? But no one's on the center of it.
X-ray it pokes through what?
It'll go all the way through the bone.
That's why it's used for X-rays.
Remember, as you go, guys, remember, as you go from right to left, what's increasing on the electromagnetic spectrum? In terms of energy, wavelength, all that stuff. From right to left. In terms of energy and wavelength. Energy increases from right to left. If you need help in that, think about it. Are radio waves harmful to you?
No.
No, radio waves will never kill you. Gamma rays, are they harmful to you?
Yes.
Yes, they will kill you. Big time.
Now, if you've been exposed to a lot of gamma rays, will it instantly?
Will it turn you into either A, the Fantastic Four, or B, the Hulk?
Studies are still being tested. Just
Whoa,
kidding.
they tested on you?
Alright, so today's an exciting day. This is where we start getting into this unit where I really like starting to talk about it. I get really passionate about it because now we're breaking outside of the mathematics and we're starting to break into the concepts. So we're going to start thinking about this stuff. So we started this class, this unit off. We started off with this question. What is light? And to answer how long they've been wondering what light is, Isaac Newton was looking and saying what he thought light was.
So it's Thomas Edison.
So this thing is like, this thing way out there, okay? So in this, you could break everything down in science into two categories. It wasn't hard to break them down. Particles or waves. You could break it down into these two categories. Now, whenever you were breaking these things down in these two categories, you've seen plenty of examples of these. This pencil, is it a particle or a wave?
Particle.
It's a particle.
Wow.
Whenever you stand...
Oh.
I made a cool noise. Whenever you stand at a pond, a still water, or a lake, and you get this big, hefty rock, and you sling it in that bad boy, gravity takes over, you get projectile motion, boom, hits the water. What starts happening?
Creates waves.
You see waves start radiating out from it, right? So there's your wave example. So the question is what is light whenever you look at this? So I'm going And let's do this. Because life becomes interesting. I love seeing what you guys think. How many of you think light is a particle? Raise your hand. And it's like pressure, like your face right there in that moment. You're like, oh God. It's like the end of the world right now if I don't get this right. How many of you think it's a particle?
I think it can be. But that's just my opinion.
Raise your hand if you think it's a particle. Go once.
I'm like,
twice.
I'm in between.
All right, we got 1.
And a half.
And a half.
Nope.
Half.
We count whole numbers here.
It's like 75.
How many of you think it's a wave? Okay, so we have a total of a whole bunch. I forgot how to count that high.
Me too.
So, funny thing is my O kind of started to look like an A there.
It's funny. A whale bunch.
All right, so in this, are you ready?
I don't know, am I?
Are you ready to find out?
Before you
Let's
attack
go.
us, I said that I thought it could be both.
Those of you that said it was a wave is right.
I did.
That's what you're looking at. Okay? Heads up, that helped you with that knowledge is we have the electromagnetic spectrum. And whenever we start with electromagnetic spectrum, what is on the electromagnetic spectrum?
But
Light.
yesterday you said that you could touch it.
You cannot touch light.
But you said I touched it. Like you did he not? He said
Yesterday?
yeah.
I don't recall.
Like, light touches you, but you can't touch light.
All right. So, here's the thing that gets interesting. What proves let's do what proof. Just because you say in English class and it sounds cool. Light equal wave.
What proof, like,
My skin is crawling.
I know it is. Y'all can take a picture of that, send it to Miss Staffy and say, oh my gosh, what is this teacher
She
doing?
can smell like improper grammar, and she just starts running down.
It'd be funny if she knocked on the door. Right? All right, so it is what proof light.
I swear she ran
I
like
have
this
a
mine.
student that's going to be passing out the mobile dentist form.
That's all she says.
Mobile dentist will be here in our school on 12/3. If you would like to see things,
I want to be having a student pass out.
All right, so listen, in
If you
this,
already see a dentist, you're to continue with your local dentist, but this is for anyone who doesn't see a dentist on a regular basis and would like to have cleanings and exams done. Thank you.
all right, so in this, what proof light equals wave? I can't even say it, it's so
What
much.
proof light equal wave?
What?
All right, so in this, here's the proof. There was a guy, English guy, and he came up with this. And I'm going to use this guy's experiment because it does such a wonderful job of showing it. It's Thomas Young.
So Thomas really likes light, huh?
Oh, yeah.
We got Thomas Young.
And it's Thomas Young's, and hopefully some of y'all in here have heard of this before. If you haven't, this is awesome. I get really excited when we start talking about
Let there
it.
be
One of my favorite experiments ever.
Let there be light.
Double.
Double slit experiment.
Is that where you
Well, that don't make me excited.
put the things and then you can see like the light and it's cool.
So this is what his double slit experiment looked like. Okay?
Say that too fast.
Thanks, man. All right, so pretty much this is like
Well, we're gonna have to
taking
do
on
this.
like a modern day twist of it, but this is pretty much like what the premise of it is. I'm pretty sure he used sunlight, but we had a light source. And then from this light source, there was this wall that had one slit in it.
So we gotta draw this.
These are your notes. You draw whatever you feel like you need to draw.
Everything the light touches is you.
So in this, where could the light come from?
That hole, that slit.
The single slit.
Yeah.
Now, since we only have one slit of light coming out, this is what he did. Because at this point, waves naturally will expand. If you don't believe me, look at my laser pointer. It's a light, right? How small is my laser pointer right there?
Very.
Okay, I'm not going to do nothing. I'm not going to let go. You guys can even watch me. Watch it.
It's getting bigger.
Just wait.
My knee.
Why is it
It
getting
became alive.
Watch it like her.
Where'd that go?
Now, how's that compare?
If it's further away.
Further away, but what is it?
It has more time to expand. It's a wave.
Yeah, it's a wave, but that one is bigger.
Yeah.
So what does it mean that it did from here to there?
Expanded, like I
It
just said.
Double slit.
You said it had more time to expand.
Oh, I mean,
But what
fair
if
enough. I'll
it
give you that.
Cut a hole, like what if it cut a hole through the ceiling? What would you have done? like what if it was that?
First off, I doubt anybody would have anything to like do with me to chew me out if I had a laser pointer that would cut a hole in the ceiling.
No, I think it's awesome.
All right, so here's what happened. These waves expanded out. These are the waves.
I like your waves, Mr. Hall.
Thank you. Now in here, this is the point that gets interesting.
It looks like an upside down.
He had a second wall here,
Ooh.
but in the second wall,
It was offset.
Whoa.
Crazy.
he left two slits.
Oh my.
I bet it was dark. It was gonna be.
So here's the interesting thing that took place in Thomas's, Mr. Young, Dr. Young's double slit experiment. The light came in through here, and then it starts radiating from here. So both of these starts radiating light.
I'm only going to put some little waves around this.
So then the interesting thing takes place. These start interacting.
Interacting now.
And the interesting thing is what Thomas had done.
He created light.
He did not create light.
Thomas Edison did that.
Actually, God did that. Thank you for.
So this is what we found. This is what he found on this back wall, which gave the proof to why light is a wave. He found different regions to where there was light that was intense, but then he found dark spots.
Okay, these just look like two dark spots on my back.
White wood, maybe.
Or just draw one darker and the other one's like not as thick. That's what
I'm thick.
And this thing kept radiating out.
I like your artistic abilities.
You're a
You're
great
the only
chemistry
person.
teacher,
Why is it none of why
but you're not a
Whoa,
art
I
teacher.
don't have
Go see
proper
G if you
grammar.
want art.
Why aren't any of them purple? Are they not important?
There's your purple knife.
Thank you. I appreciate it.
Important.
Import.
Ant. We have an import ant. It's coming from Europe.
Import and question mark.
Foreign.
Yeah. Something like licky.
T-hop.
Like that. Yeah.
All right, so import ant. This whole thing is important. Why? This right here shows something special. And this is why that they ain't in purple, because it's going to be a purple
Aren't.
now.
Aren't. That's why they aren't in
This right here is a special thing. And it's what we've seen. Like if you want to test it, you can go out to some local pond that's got water that's still, and you can take 2 rocks, sling them out, and you'll watch it. The waves will radiate outward. And they'll keep expanding, but then something will happen when these waves hit each other.
Kind of like when you're kayaking and a boat goes by and you about to fall off because there's like 2 waves coming and it hits you.
And it's just like, you tip
Not
over.
really.
You tip over.
And then you start drowning and you get out of the kayak and die.
The wave just keeps hitting your face.
Yeah.
Something like that.
This showed an interference pattern, which is a property of light. What will happen with these is that light will actually interact with itself. And you'll find spots to where the light's good. They could even increase. And you'll find spots to where the light does not exist.
Wait. That's why when I'm like, okay, you're standing on a baseball field and all the lights are shining down from different directions. There's like 4 shadows.
And then it hits your eye
And
and
like,
you're blind. Yeah.
where the light's not shining, there's like a shadow one way, and around it, it's light everywhere else. And then once you get closer to yourself and you're like standing, the shadow is completely like even darker than what it is in like the next. That's hard to describe.
That's why you can
Yeah, that was
Like if you knew what I'm talking about and knew what I was like, see.
Alright, so in this,
Yeah, that's why we never want to get into doing chemistry on the field.
I'm slightly.
Is this going to be on our quiz Friday?
Only slightly.
did I teach you?
So yeah.
Uh,
I want to get me like that. I just asked this for everybody in this class.
Wow, he's getting fancy on us, man. He's got a ruler.
that's
Shows like you've drawn all your
Yeah.
video.
And
It's
even that's
okay.
probably.
That helped.
I'd say probably credit too.
Yeah, the second one was
Cricketer.
Wow, you stopped that line perfectly on the other line. That's good. I like that.
There was your videos. That one didn't.
So this is what takes place. This is what's happening that creates this interference pattern. Remember what we talked about when we talked about these waves? Is they have different parts. Remember, up here at the top, were the crests. At the bottom were the troughs. And a special thing happens here. If you find a spot to where crests match up, remember this was freehand for anybody starts going, that ain't a straight line. That ain't lining up with the hawk, whatever. This is used as an example. Don't judge me on my artistic skill. This right here is where you would find a red spot. This is where you're still seeing light. But if you would find a spot to where trough and crest met, I should do that in a different color. Here.
Like on the, do those get like, are they supposed to get bigger?
Not really, but they do. Right there's good.
Mine's kind of wonky, but whatever.
So you find a spot where a trough, there's a trough, and a crest meet. At those points, you find the black spots.
What about a trough and a trough?
Because at that point, they're canceling each other out. They kill them
Oh, wow.
to where there's nothing there to be seen. And that's why we see this interference pattern happening. Since we see an interference pattern here on the back, we know light is a wave. It is proof that light is a wave. So who proved that light is a wave?
Thomas Young.
Thomas Young. What proved light was a wave?
Interference pattern.
Double slit experiment. Why did the double slit experiment prove that light was a wave?
Because the interference pattern showed.
Because it showed an interference pattern on the screen. Now, you want to know what we're going to do tomorrow?
Sure.
We're gonna do it.
You ready to hear this?
We're gonna do the split.
Are you ready?
We're going to set things on
Caitlin was
fire.
right. Light is a particle.
I was right both ways.
That was like a really high pitch. Just rolled right up there. Tomorrow, when you come in here, what you're going to flow through is we talked all about how light is a wave. Now, tomorrow, we're going to come in here and talk about why light is a particle. Who proved light is a particle? How is it proof that it's a particle? Where do we have evidence that light is a particle? Where's all this coming from? Yes.
Fire.
Yeah. But more scientific than that.
Energy.
Was it?
Yes, but more scientific than that.
Was his name
You can
Thomas?
get worse
Is his
by
name
science.
Thomas? What? Question
Yeah,
mark?
what's his name?
No. This scientist you know and you know him very well.
Thomas Edison.
Avogadro.
Please make sure my calculators are put back up. Guys,
No, it's one.
hey, if there's anything I can stress to you, don't get so caught up on the math of this.
Is it Newton?
You need to know the math. But science is not just about the math. Science is also about the concept. You need to know these equations that go with all this, but you need to know the interference pattern. You need to know Thomas Young. You need to know the double slit experiment. You will hear this again.